edge, because you guys, like Emilio, sit one step further away from the end user. Okay, thank you all for coming. Răzvan is going to be telling us about OpenSIPS. He's been part of the project for 8 years, a little bit more than half of the project. And in his spare time, he teaches people about operating systems, actually, at university. Yes. Take it away.
So when Dan asked me to come here and present OpenSIPS, I was honored and very glad that we can take part of the very first edition of the ComCon. However, I was a bit concerned because usually when people ask me when I talk to people about OpenSIPS, they either ask me a very, very specific question, a very technical question, or they just ask me what OpenSIPS does. So not knowing all of you very well and not knowing how this will go, I decided to go to the more generic presentation and present to you or show you where OpenSIPS stands in the entire SIP ecosystem. A couple of things about me, Eric already said them. I've been working with the OpenSIPS project since 2010, and throughout the years I've become one of the core developers. I've been developing both a lot of modules and a lot of core stuff in OpenSIPS. I'm actually one of the WebRTC WebSocket, actually the WebSocket module writer, so probably that's why I'm here and not my other colleagues. And throughout the years, I've designed and implemented various voice over IP platforms that have OpenSIPS in their core, and they are serving like millions of subscribers, thousands of calls per second. I'm also a speaker. Usually I speak mostly about OpenSIPS in different conferences like OpenSIPS Summit, ClueCon, ASRICon, FOSDEM, and now ComCon. And I'm also a teaching assistant at the Polytechnica University of Bucharest. I teach compilers, operating systems, and stuff like that, so low-level stuff. Unfortunately, we don't have a VoIP track in our university, because if we had, I would have taught that as well. So today we'll be talking about the SIP ecosystem, how the SIP ecosystem looks like, its components, and OpenSIP's role in this ecosystem. We'll zoom in to see exactly how we can help a VoIP platform, and after that we'll draw some conclusions. So what is the VoIP ecosystem, let's say? It consists of multiple levels. So if you want to make a call from A to B, it's just not A to B, right? There are a lot of hops between A to B that ensure all the communications and the services that a VoIP platform, a VoIP ecosystem offers. And it's very important to know this ecosystem in order to choose the right tool. We don't just take a project and put it there. We have to foresee and understand the entire system in order to choose the right tool to do it. And in order to help you understand how this works, I will make a simple analogy with the IP interconnection chain. Okay. So let's start. How does a call start? Well, we have a user that is calling, right? A VoIP user. Similar, when we want to access internet, we have a computer or a mobile phone. What's the first hop when you try to make a call? Okay. So when we try to connect to a service, what's the first hop that we hit? It's a router, right? So we first go to a router, and usually this router is basically on premises, so it's next to you, in your home, in your house, and it works as a local gateway, and its job is to break out. it's very skillful as features because it can offer like a lot of DMZ stuff, like local routing, but it's not very highly capacity. It doesn't have so much capacity. It's basically a low or probably medium capacity, only used to route between a couple of computers inside your local network. In the VoIP world, its equivalent is an IP PBX. So what does an IP PBX does? What does an IP PBX? It basically routes local calls inside the house. It helps you transfer a couple of calls, but it's not very high capacity. You can throw thousands or millions of calls in this instance. Now, so reaching the first hop, you have to break through. You have to reach the internet, right? And how do we do in our home? Well, our router goes directly to an ISP, right? An internet service provider. This internet service provider is used to route worldwide. It has a lot of complex routing logic. It doesn't offer too many services except routing, and they don't offer too many services, but it has a lot of capacity because it has to interconnect all these local areas, local houses, local sites. In the VoIP world, this is the equivalent of a SIP provider, and I've seen a couple of SIP providers here. Basically, what they do is have a pool of customers that connect to them, and from them they can reach all the other components. But it's not that simple, right? You can't just go from your local IP through the router and directly to the ISP. Why? Because there are a lot of security concerns. And in the IP world, we use a firewall for that, right? This firewall is used to prevent unauthorized access to the ISP and enforce some security policies and stuff like that. It also has a very complex routing logic. It also needs very low-level skills because it has to detect any malformed traffic or any unauthorized traffic from or probably malicious traffic from these guys. And it has to be very high capacity because, again, he links all these local homes before the ISP. The equivalent in the SIP world, in the VoIP world, is an SBC, a session border controller, which basically does the same thing. It enforces security and security for the SIP provider. It normalizes traffic. It denies any unauthorized traffic and any malicious and malformed traffic. And it needs to be very high capacity. So now that we reached our ISP, we need to access a service, for example, right? Therefore, we need an application provider. Basically, this application provider provides content. It has a lot of complex applications in order to provide that content. It needs a lot of external interaction, so different applications need to interact between them. And due to the fact that it has a complex logic, his capacity might become a bit lower. So we might have a medium capacity. In the VoIP world, basically we have the same. We have application providers or service providers that provide content or provide services to our users, to the VoIP users. So basically, this is how the entire flow looks like. A user goes through a local SBC, is authenticated by an SBC, which goes to a SIP provider that identifies the service this guy needs and also provides it. let's see where OpenSIPS exactly fits in this ecosystem. So the color, the SIP client is basically either a hard phone or a cell phone. It can be a mobile phone or probably most likely a WebRTC client. So probably most of the guys that are in this conference either do cell phones, either build mobile apps, but probably most of them are doing a WebRTC client. Therefore, OpenSIPS is not for that, right? As a local PBX, it needs to have a lot of features. It has to handle media. It has to offer a lot of class 5 oriented services. Therefore, OpenSIPS does not do any media and is not actually back-to-back, although we do have a lot of back-to-back support. It doesn't really fit as a class 5 solution. However, a popular candidate is always FreeSwitch or Asterisk, which offers a lot of class 5 features. When we get to an SBC, a session border controller, as we said, a very high throughput is required because it has to handle a lot of local PBXs from all over the area or for all over the country, let's say. And it has to be to have a lot of flexibility because it needs to detect any malicious traffic and block it. It has to normalize traffic, to enforce certain security policies like access lists and stuff like that. But this is an ideal job for OpenSIPS because in OpenSIPS we can do that very, very well. I will show you a bit later how. But let's go to a SIP provider. A SIP provider is a very high throughput because it also has a lot of complex logic for routing. So having a lot of complex, again, makes it a bit hard to scale. However, we can cluster all multiple OpenSIPS instances in order to offer a single unified platform. Therefore, we can enforce powerful services. However, we are still not handling media because, well, you know, if you handle media, you have different other pains. Probably Lorenzo knows better. But it's still a great job for OpenSIPS to work as a SIP provider. As an application provider, okay. As an application provider, OpenSIPS doesn't really do any, cannot really do any application services. However, it can act as a front end. What does an application provider? It basically offers different services. Most of them probably media services. That's why OpenSIPS cannot do it. But OpenSIPS can, for example, dispatch to a bunch of these application providers and offer high availability and do all sorts of load balancing logic between them. Let's zoom a bit in. So OpenSIPS as an SBC, it can do a lot of stuff. One of them is transport protocol conversion. Imagine here that you have a user agent client that is using plain SIP, but you have another smartphone that is using TCP. You might also have a provider that is a browser that is using WebRTC. You have all these different types of communication, all rely on SIP. OpenSIPS can convert them towards the core network in a plain UDP, simple plain UDP protocol. So here you can have whatever SIP-enabled protocol over TCP, over TLS, over WebRTC. OpenSIPS will normalize them and convert them to a UDP so that here in the core network you only have to deal with UDP. It can also do mid-registration and aggregation. So imagine here that you have Alice that is registering from 3 different locations with, and that he wants to get calls on each one of them. this guy doesn't really need to know that Alice is registering from 3 different sites. It will only know that Alice is here. So if you want to reach Alex, just go to this SBC. And this guy will know where to dispatch these calls. This means that you don't need to flood the entire core network with registrations as long as this guy knows how to reach Alice. We are also imposing a lot of SIP security. We can do user agent filtering. We can do IP authentication, user authentication, and so forth and so on. This guy also needs to handle NAT traversal because he's the one facing the user client, right? So he's the one that needs to keep the pinhole open towards the user, sending pings and making sure that the router is not closing the pinhole, the connection. And one of the things that we are doing is network bridging. So imagine that all these guys are in the public internet, right? But here, you don't want your core network to be accessed over the internet, over the public IP. So here, you might want to have this your core network, your core system, to have it in a private network. That's where OpenSIPS SBC comes into help because it can easily do translation or bridging between the public internet and the private network. And you can also enforce distributed and parallel traffic shapings. For example, you can enforce distributed calls per second limitations or parallel calls limitations. You can also do distributed security alerts. For example, you can sort of distributed DOS, denial of service. You can address it very well, very simple in an SBC. As a SIP provider, OpenSIPS can act as a registrar and a trunking server. So it can handle thousands, millions of registrations at a time. It can work with millions of calls per second. So it can easily act as a trunking server just simply by relaying calls. It has a lot of features for AAA, for authentication, authorization, and accounting. It also can act as a presence server. It can enforce several dial plans and normalizations on the traffic. You can enforce over there advanced signaling services. For example, if you want to offer call forwarding for your clients or do not disturb buttons that can be controlled in a web interface. So it's very flexible in this type of scenarios. But most of the things that you want to do in a SIP provider is to provide complex routing logic. So not sure how many of you are a SIP provider, but you know that you know how hard it is to interconnect with different carriers that offer different rate sheets, and how hard it is to choose which carrier or which gateway should terminate a call, whether that gateway is up and down, to do any failover in case the gateway is down because you really want to complete that call, and you want to be charged at a minimum rate. So you have to do all CR and stuff like that, but for a specific prefix. You might also want to do some load balancing in case a carrier is too loaded. Even though it's very cheap to use it, you might need to go to a different one because you offer, I don't know, premium services for certain rates. We can also have logic to prioritize 911 calls because, as far as I know, this is enforced by several laws. You have to prioritize 911 calls. So you cannot deny them. In OpenSIPS, we also have call queuing for those that want to have a call center as an application provider. You can do the dispatching on the OpenSIPS side. So we have all the flows and queues and skills that call centers have and need. You can configure them in OpenSIPS and it will just work. And we can also use external logic to provide different services. For example, query an application logic in order to find out where a call goes. You can even write different scripts. You can write the logic in different scripting languages such as Lua, Python, Perl, and so on. From the applications perspective, OpenSIPs can easily do some dispatching towards your real application service. As I said, it doesn't really act as an application service, but can be very helpful to dispatch calls to these servers. It can do very smart routing. For example, it can be aware of service particularities. Practical example here is you start a conference bridge here on this application server, and you get another call for the same conference. You don't want to send it here, right? Because, well, there will just be two different conferences. OpenSIPs will detect that there's an ongoing conference call and will route it over here very easy. And this also provides a lot of high availability for clustering and failover support. So if this guy is not reachable, OpenSIPs can easily move the call here or start the call here. It can also enforce traffic throttling. For example, taking different, let's say, useless traffic, strip it, and prevent these guys from being overloaded or flooded with unuseful traffic. And again, can do network bridging and access control for these servers. Of course, it's not only us doing this. We have a lot of other components that help us doing this. And in order to, in this ecosystem, and in order to offer all these services, we do need other products, other services, or other, we do need and use other projects. One of the projects that we are working pretty well with is the Homer project, which allows you to do any kind of SIP debugging with it. And in OpenSIPs, we have developed, as far as I know, we are the most advanced users of Homer, and we've developed a lot of features to publish SIP to Homer, but not only that, we can publish logs. We can also publish networking information. For example, if you are using a TLS, we can publish all the certificates that have been used to establish that connection. Or if that connection doesn't establish, we can show the certificates being used, and so that you can debug why the connection was not completed. So we have a lot of integration with Homer. We can even trace, for example, REST queries if you are using REST to do external routing. We also have support for Sangoma cards. If you want to do hardware transcoding, we have some libraries that we integrated with Sangoma, and you can do real-time transcoding using dedicated hardware. CG rates, probably most of you, if you are doing billing, you are using CG rates or something else, or probably A2 billing. But CG rates is a pure open source project that is used to do billing, and we've got a dedicated interface with it that it just works. You set it up and billing is just works. Of course, you still have to do some configurations on the CG rates side, but from the call control part, it's all being done. As I said earlier, we are not handling media. However, we do have a couple of projects that we've interconnected with to do media, for example, media bridging or media streaming, such as RTP proxy, media proxy, or RTP engine. Probably some of you are using that. In order to offer even more services, we have different interfaces for management. For example, you can query OpenSIPs for different statistics about calls, about OpenSIP status. we can trigger events to your external application. So for example, if you have a RabbitMQ broker, we can publish events to that broker and somebody can listen to them, even CDRs or whatever events you want to publish. SQL, and we both support SQL and NoSQL, both probably all the database engines that are out there, both SQL and NoSQL, we support Mongo, Cassandra, I don't know, MySQL, Postgres, DB Oracle, whatever you want, we have them in there. And if we don't, just tell us. So, in conclusion, in the SIP ecosystem, in the VoIP ecosystem, we are used to split the traffic in two different categories. One of them is originating and terminated traffic, which requires a very dynamic and a very large set of services and skills, typically class 5 services, and they really need to handle media because, well, that's what those services do. And the other category is carrying traffic, which requires very high capacity, a way of clustering, a way of offering high availability, failover in case of problems. It also needs to have really complex routing logics, but it also needs to be adaptive and very flexible in order to offer, in order to ensure security and normalize the traffic that goes towards the core network. So we split this in two different categories. The first two are basically not our job. So we don't do user clients, we don't do PBXs, that's asterisk, free switch zone, Janus, or whatever you would use. We don't do application provider 100%. We just do dispatching towards the application providers. However, as an SBC and a SIP provider, this is OpenSIPS zone, and this is what we do best. This is what OpenSIPS has been built for. So in conclusion, you have to use the right tool for the right purpose, and you have to take into account the entire SIP ecosystem when you build a SIP platform. Otherwise, you might need with bits and pieces that don't really fit, and you have to foresee this in order to prevent it from the scratch. If there are any questions about OpenSIPs or about the SIP ecosystem, about anything, just let me know.
I didn't raise my hand. We have a question, but it's more, you know.
Raise your hand. One-on-one. Okay.
I'd be curious if you could explain, the licensing agreement and sort of the business model and how that works.
So it's completely free. It's a GPL2, actually 3 license, so anyone can use it. You just take it and use it. There's no enforcement on the commercial side. That's it. Thank you very much for being here, then.
Thank you, everybody. We now have a coffee break, so feel free to go out and see what's